Red Elk runs with a purely horizontal velocity and lands 8.6 meters from the base of a 13-meter tall cliff. Let's draw a picture of this. Wobbly. 8.6 meters from the base would be this distance. All right, so he goes. Poor Red Elk, he keeps running off cliffs. And then the cliff is 13 meters tall. Okay, now, in every single projectile motion problem you ever do, you're going to know this and this for the planet Earth. If you're on the moon, this one's different, this one's not. Okay, so those are always true. For cliff problems like this, where it's a purely horizontal velocity, we also know this, right? So you can fill that in. You can fill that guy in, right? Okay, but in this case, we also know this, and we also know this. Okay. So see if you can fill those in. I'm going to pause here. I'm pausing. That's why I'm like not moving the pen. All right, here we go. Okay, so this is 0 and negative 9.8. This is 0 because it's a purely horizontal velocity. And then the cliff is 13 meters tall. So you're going to go from here to here. You're going to go down 13 meters, right? Okay, and then this distance is 8.6 meters. Okay. So those are the things we know. This is interesting. Okay, so I think we can do this. I'm going to start with the vertical side. I can't do anything in the horizontal side, and that's because I need to know there's three things, right? There's this guy. These are just really one guy, right? And this guy. I only know one of those, so hopefully I can get the time on this side. It's looking good, though. So in the vertical side here, let's find the final velocity. I'm going to use no t for that. All right, so let's see. VF is the square root of 0 squared, right? Plus 2 times negative 9.8 times negative 13. The two negatives make it so you don't get an error message. So square root of 2 times 9.8 times 13. This is 15.962 meters per second, right? The absolute value of VF is that, right? Of course, it's going to be negative 15.962, right? We have to put a minus sign on there because it's going down. And the calculator won't do that for you. It's the one case where it won't. All right, so let's look at the time. For this, I always use this to find the time. There are other ways to do it. 1/2 AT squared, right? So negative 13 equals, and the initial velocity is 0, so that whole term goes away, right? So it's 1/2 negative 9.8, and then t squared, right? So to get that t alone, here's what you do. So just follow along with me. Type in the negative 13, multiply by 2, go times 2. You can hit enter if you want, that's fine. And then divide by negative 9.8. And I get the 2.65306 equals t squared. That's not t, that's t squared, right? So now I'm going to square root both sides. So I'll go second square root, second answer. And you get 1.6288. Right, and that's our time. And of course the time can go across. Right, and now on the now we're ready to do the horizontal side, right? Okay, and then all we ever do in the horizontal side is use the formula v is x over t. In this case, we are solving for the velocity, so it's easy, right? 8.6 divided by 1.6288. So I'm going to go 8.6 divided by answer, and you get 5.27988. $27988. All right. All right. Now let's answer the question. So 5 says, what time is he in the air? And that, of course, is going to be this guy. So I'm going to say 1.63. Here's where we find out. Did I get it right? Yes, I did. All right. B says, what is his horizontal velocity? That's going to be this guy. No. Sorry, that's going to be this guy. Okay, so 5.28, I guess. All right, did I get that right? Ooh, I sure as heck did. All right, C says, what is his final vertical velocity, right? And that's going to be this guy. VF is equal to negative 15.962 meters per second. All right, now the final thing is it says to draw a picture of that vector. I'm going to erase this in 3, 2, 1. It's gone. All right, remember that we've got this velocity vector, and our sideways velocity was 5.27988 meters per second or something like that, right? And then, so draw that to the right, and then from the tip of that, draw your y component. And the y component was, what was it? 15.962 meters per second, right? And that was negative. This guy was positive, right? So draw these components tip to tail, right? And then the vector does this. It's harder to draw with a bamboo stylus than you think, right? So make sure your vector is an arrow, right? So you get 2 points for just a good drawing, right? And now we get 2 more points for getting the angle and the magnitude. So that angle there is going to be the inverse tan of 15.962 divided by 5.2927988. Let's do that. All right. Okay, so here we go. Second tan of that guy divided by this guy. Hope that's right. 71.7 degrees. Ooh, I'm getting the right answer. 1.7 degrees. So that angle is 71.7 degrees. And then the speed of this, the magnitude, is the speed of the object, right? I'm going to find the magnitude by going this guy squared, so 5.27988 plus 15.692. 962, wow. 962, that, right? Okay, so here we go. The square root of this guy. I'm using the arrow key on my calculator. That guy squared plus that one squared. 16.8. That equals 16.8 meters per second. That's the speed of the object. All right. So here's how you're going to show me that you've got the right answer for this last one. Okay, you're going to show the components as arrows. You're going to show the velocity like this, okay, going from the tail of the first component to the tip of the last. Your magnitude is going to be an arrow. You've picked some angle. I always pick that angle, okay, and you've labeled what it is, and then you've calculated the magnitude, the length of the hypotenuse, okay? Go Wolves.